So let's consider a circular loop again, and we have a point on the axis. So let me show you what an axis is. So we have the same circle kind of thing, right? And we have this green line passing through the center. So that's your axis. So here OP is your axis, and P is the point at which we are trying to figure out the magnetic field. So if AB is your diameter, OP will be a line that is perpendicular. Done, that's your axis. Next, we have to figure out how each of these elements, say element at A and element at B, and so on and so forth. Each of the element that you see on the screen, how does it affect the magnetic field at point A? That's what we are trying to figure out. So how do you do that? First, let's consider the current. So let's look at the derivation. Let's consider a circle with wire with radius A. So that's A, carrying current of I. Okay. Let us consider a point P at a distance R from the center O. That's the center O. This is distance of R. So OP is R. So let's consider a small element. So the element is over here, DL. And we need to point the direction as well. It is always tangential. So this is tangential. So that's a tangent. Okay, guys. At the other end also, we will have a tangent. Right? So there is a key point. Okay, I'll come to that. So according to your Savart silicon tolerance. So that law, the field at point P is given by, it depends on the current, it depends on the length, it depends on the angle between what? Yes, we'll discuss about that. And it depends on the distance from where, from A to point P. So we'll call that as S as of now. It will be convenient, S square. And of course, mu naught by 4 pi. Now let's talk about angle theta. Here theta is equal to 90 degree. Why is that? As DL being tangential to the loop. So let me do that. Let me do it here. So when I see it from the front view, what is that we are looking at? So if you see this, right? This line, which line? This line. From the top to the bottom. Okay, imagine that line. Now draw a tangent. So you can imagine this line over there. Actually, I can draw a tangent. I could have. Anyways. So if you imagine that line, what is the angle between them? Yes, it will be 90 degree. Actually, the right way to view it would be something like this and over here. You can imagine that, right? Over there. What is the angle? Again, please don't consider this entire surface. Just consider this line. So what is the angle? It will be correct 90 degree. Is it not? So basically this and this line will make an angle of 90 degree. Something like this. Therefore, dB is equal to mu naught by 4 pi IDL by S square. Okay. Now, what is the effect of, say, one component? It would be perpendicular to AP and perpendicular to DL as well. It's a cross product, right? It has to be perpendicular to surface containing DL and S. So that's your dB by A. Right? Let me explain. Actually, I made this to show those 2 points only, the directional aspect. So say this is your dB from the top, right? And we have the tangent. So the plane will be something like this, whatever this greenish, bluish, right, thing is, that will be your plane. So perpendicular to that would be something like this. Okay, view this. This will be a 90 degree. Okay, think of it. This will be 90 degree. It has to be perpendicular to this surface, the surface being this. To that 90° looks like this. Not that. Yeah, this. So to this plane which contains the element, position vector and the tangent, this line is 90°. So if that is clear, you need to understand that at this end also we'll have dB but with respect to B. So now moving forward, what should we do? Let's figure out the effect of one of this pair, right? So moving forward, the net effect by diagonally opposite elements of the loop would be what if I consider this as your axis, this as your, sorry, not that, this as your point P. So we can see that this would be your dB by A and this would be your dB by B. Actually, you guys need not draw extra diagram. You can do it over there, but you can clearly see that this has an advantage. Clarity. Now we need to add this up. If we know this angle, we'll be able to add it up. Or we can resolve it and add as well. For that also we need angle actually. But which angle? Which angle should we take? We'll take this angle. This is fixed for a given point, right? And this two are equal to each other. Now the question is, how should we resolve and what are the angles over here? So we'll resolve with respect to the axis, that is for sure. One is along the axis and one is perpendicular to the axis. In this way. This is along the axis and this is perpendicular to the axis. So how is phi related to them? Which angle is phi? Is this angle the phi or is this phi? That is something that we need to answer next. So we took phi, we took that, let's take this as phi. So how will I resolve with respect to phi? So first clue is the diagram itself. Second clue is this to our 90°. One is horizontal, one is vertical. I mean, that's the whole point that you have taken. Next clue is this line and this being 90°. Next clue is this is perpendicular to this. Are you guys able to figure it out? See, this will be 90 minus 5. This will be 90 minus 5 plus 90. So basically, sorry, other way around. 90 minus of 90 minus 5. So that will be plus 5 and so on and so forth. So yes, indirectly, what I'm trying to tell is this angle will be your phi. So once we know that, we can resolve it as simple as that. So that's your phi. Okay, guys. So when we talk about this length and the set of lengths, this will be dB cos phi and this will be dB sin phi, but they will add up. So this will be dB sin phi plus dB sin phi. So this will be 2 times of it. And here it would be dB cos phi. This is the entire scenario. Okay, does it make sense? Think about it, take a second. Right, done, it's clear. So what's happening over here? The parallel components are adding up, the perpendicular components are cancelling each other. So let's write that. On resolving, we get to see that on resolving, the dBs with respect to the axis, right? We get the above components actually. Clearly, the perpendicular components cancel each other while parallel adds. I mean, it's not a exact language, but you guys understand. So the net effect of A and B is equal to 2 dB sine phi. So next, P, the net effect at point P because of all the elements will be sum of all such pairs. We're talking about pairs, by the way. Wait just a second. So B is equal to integration of dB net effect by A and B. So we are integrating from, half the way. What I mean is starting from A till B. If I go one loop, by default, other loop will be added by itself. Example, if I extend this, okay, I can't, you guys might not be able to see that. Let me do this actually, just a second. If I add this much, at the other end, same amount will be added. If I add this much, same amount will be added. So if I add a bit more, say till here, so other end, that amount will be added because we already taken one pair. So all the other pair also will work the same, right? So by adding half the way, the formula or the scenario will take care of the other half because we already added the pair. There's a 2 already. So B will be equal to 2 times of integration of dB sine phi. Sine phi is also constant because for a given point phi is constant, right? Now let's substitute 2 u naught by 4 pi. Integration of I is also constant. dl is what we need to add, s square into sine phi. Okay, sine phi, let's substitute it off. Sine phi is opposite by hypotenuse. So a by s. A by s. Pretty much all the values are constant. So we have this 1s are 2s are. This will be equal to mu naught by 2 pi I a s square integration of dl. So the integration of dl is, you just have to consider half the way. So this will be mu naught by 2 pi I a s square pi a. So pi and pi get cancelled and we have, just a second. Oh yeah, sorry, this is cube, my bad. And we have in the numerator, we have mu naught by, the first term is that, in the numerator we have I a square by, denominator we have s cube. Okay guys, please be very careful. Let me write it over here. Just need to add half the way. Just need to add halfway because it's a pair. Of diagonally opposite elements, right? All of that you guys can write. So that's why this is pi a, half the circumference. So that is your final expression. But yes is not something that your final answer should depend on. it should be dependent on your a, the radius of the circle, and in terms of how far it is. So we need to express in that manner. That should be the variables. Final expression should have those variables. So as per the Pythagoras theorem, S is nothing but r square plus a square. So we have mu naught by 2 ia square divided by a square plus r square to the power of, that will be 3 by 2, 1.5. And now it is your final expression. My bad. So same thing for n. This is for one loop. For n number of loop, it will be into n. So you guys can do that for n loops. That will be n times of the above expression b. Okay. Actually, this is part of special cases. Now let's see. Let's verify the final answer. So when point P is at center, so basically this point goes to the center. It's over here. If it goes to the center, what will happen to this distance? Yes, that will become 0. So in this case, r is 0. R is not the radius. It is the perpendicular distance. This will be, therefore r will be equal to 0. So b we have u naught by 2 ia square divided by a cube. 2 into 1.5 is 3. So this is mu naught I by 2a. Right? Makes sense? So b is equal to r when r is equal to a. So this will be mu naught by 2. This will be a, ia. Oh, this will be the same. Is it? No, 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 it won't be the same. Sorry, my bad. Root 2. A square by, this will be 2a square, guys. All to the power of 1.5. Array, this will be 1.5 is nothing but 2, 4, 2 will come out. No, 3 by 2, that will be 2 to the power of 1 into 2 to the power of half. So mu naught by 4 root 2 I by a. Yeah, I don't know why is this a special case, but it is so. Okay, then what else we have? For very far away, so r is a lot bigger than a. So this will be mu naught by 2 ia square divided by, this will be r to the power of 3. Okay guys, finally let me draw the graph. Let me take a second. Okay, so last bit. So we have this to be your b, that's your distance. So you go left or the right of the circle, the effect will be the same, just that it's on the opposite side. It would be something like this. It's reducing at a rate of cube, right? So it would be so. It'll be the maximum at the center, obviously. So that would be your expression. Please write your expressions over here. So mu naught I by 2a, right? And this is fourth root and all of that when r is equal to a, maybe somewhere over there, or r is equal to a. So same expression, mu naught I by 4 root, something like that. Okay guys, and here it is reducing at a rate of r cube, far away. So that's that. Okay, now it's time for you guys to pause and write.